So y'all may hear some gentle video game noises in the background. We got a game of Pokopia going. Just letting you know if you're the type of person that has to figure out what the noises are, that's what they are. Um, so we are looking at the final exam review. We finished all of the Amplify. So the way I usually run these is I let people pick which questions we're going to look at. So that's what I'm going to start it out with. Open the floor. Does anyone have a number in particular that they wanted to see worked out that they had questions about? You can say it out loud or put it in the chat.
Could we start with number one?
Sure. So number one is a nice little classic domain question. You're not going to have all three of the functions on the test. It's just going to be one function, the more complicated of them. But when you're looking to answer this for webwork, though, we got to answer all three. So all three of these are fractions with denominators. One of the domain restrictions is that we cannot divide by 0. So if there is any sort of variable in the denominator, we're supposed to check and see where would that denominator equal 0. So for this quadratic here, I'm going to figure out what values make that 0. And then those are the values I'm going to say are not a part of my domain. Now, this particular quadratic does factor. But if you're not comfortable with factoring, you could also use the quadratic formula. But here, only helpful way to get 14 is 7 times 2. But they're both going to have to be negative to add to negative 9x. And now that it's equal to 0, I can set each factor equal to 0. So we have x minus 7 equals 0, or x minus 2 equals 0. So we have x equals 7, or x equals 2. So these are values that the domain is not allowed to be. So on our number line, I'm going to drop those two values in particular. 2 and 7. So when we say it's not allowed to equal these values, we give them an open circle. So the values that are part of this domain are everything before 2 down to negative infinity, everything between 2 and 7, and everything after 7 up to infinity. So this domain has 3 intervals, from negative infinity to 2, from 2 to 7, and from 7 to infinity. So that's just how to answer that one for webwork. Now for the final, we're going to have one with a square root in it. So the square root has its own domain restriction. So I'm going to have 2 parts to this domain. I've got the first part where the bottom is set equal to 0. So I get x equals negative 2, but this is my don't allow it value. So x can't be allowed to equal negative 2. And then the other result is going to come from inside our square root. Square roots are not allowed to apply to negative numbers. I can't take the square root of a negative number. So I'm going to set the inside of the square root greater than or equal to 0. So this is saying it can only be positive or it's allowed to equal 0. And if I minus the 8 over, I have x is greater than or equal to negative 8. So now we're going to drop those two values on our number line. So there's negative 8, and there's negative 2. Negative 2 gets an open circle because we're not allowed to hit it. Now x is allowed to equal negative 8, so we'll give that a filled in circle. And x can be anything bigger than negative 8, so all the numbers from -8 to -2, and all the numbers from -2 on to infinity. So I have two regions that I need to account for in my answer. So from -8 to -2, and from -2 to infinity. Infinity always gets a parenthesis. The -2, because it's an open circle, because we're not allowed to equal it, also gets parentheses. But the -8, because it's included, we're going to give it the different symbol, the bracket symbol. And then we just stick those two things together with a union symbol. Now, this question is multiple choice. So you still got to understand the difference between the answers, but you can like look at the problem, look at the answers and figure out, oh, it's that one. So you can actually do this problem without really showing any work, and that's fine. As long as you picked the correct answer, you get full credit for it. But if you picked the wrong answer, but your work shows me that you were still doing some good work, you just made a small mistake, I can still give you partial credit instead of no credit. So it is to your benefit to show your work. On some of the questions, you have to show your work because there's no multiple choice. And it's about half and half. I think it's like 8 free response and 9 multiple choice, maybe. But that's how we tackle that domain for, at least 2 of the 3. So does that make that one make more sense? You kind of know what to expect on the test? All right, what's another one we can take a look at? Yep, question number 3. All right, so question number 3 gives us a nice little setup. They tell us the cosine, and they tell us what quadrant the angle is in. So our first step is draw, if they go to the effort to tell us where the angle is, draw the angle in that quadrant. So I stick a line into quadrant 3 from the origin, diagonal line out there. Then I'm going to draw from the end of that line back to the x-axis. That's our height of the triangle. Our angle in question is angle T over here. Now they told us the cosine of T, the cosine of angle T is -4/11. Now let me be very clear here, because I had a lot of people, not just a few, but like more than a few, decide that this sentence meant the angle is -4/11. That is not what this sentence is telling us. This math equation, the cosine of T is -4/11. The angle is some other number. I could figure out that angle, but that's not what this question is asking me to do. This question is asking me to answer what the other 5 trig functions are. So I need to use the one trig function I have. I have the cosine of T. So this is where our hippies come into play. So we have some old hippie caught another hippie tripping on acid. So caught another hippie, this is another over hippie, which is synonymous with adjacent over hypotenuse. So when we come back to our triangle, our hypotenuse is the diagonal side. So that is going to be +11. Our adjacent side is the horizontal side next to angle T. So this is going to be -4. we need to figure out what the vertical side is, which is our opposite side. Now I know two of the three sides of a right triangle, so I can use Pythagorean theorem here because I know it is a right triangle. So I'm just going to call that y. So we're going to Pythagorean theorem to get that third side. So we have -4 squared plus y squared equals 11 squared. Now all of these sides need to go in parentheses. So -4 squared with the parentheses is +16. Plus y squared equals 11 squared is 121. If you don't have the parentheses and you type the negative of 4 squared, the calculator will do the exponent and then make your answer negative, and it'll tell you it's -16 because you didn't write the parentheses, you didn't type the parentheses. The calculator is not wrong. It just did what you told it to do. It did the exponent before the minus. So this is why when we're writing our math, we need to be careful about what we're writing. All right, now we're going to solve. I minus the 16. And this gives me the square root of 105. Which is 3 times 35. That is 3 times 5 times 7. So it's a composite number, but it doesn't actually simplify in terms of a square root. So we're just going to leave that as the square root of 105. Now, y squared is 105. We take the square root, we have to remember the plus or minus, and in this case, the y side is going down, so we are going to use the negative. So y is negative square root of 105. All right, now on the test, you're not going to have to answer all 5 of the trig functions. You're just going to answer one of them. But you don't know which one, so we'll go ahead and do all 5 now. All right, so we've got sine of t. I'm just going to write all of them down. It's not necessarily in the order being presented, but we need our reciprocals of each of these. So the reciprocal of tangent is cotangent. And then we've got secant and cosecant are supposed to go with sine and cosine. But remember, the s's do not go together here. So the reciprocal of sine is not secant, it's cosecant. The reciprocal of cosine ends up being secant. Now they defined for us, the cosine was -4/11ths. So we know the secant then is -11/4. It's just that reciprocal. We figured out that the sine, we figured out the opposite side. Sine is opposite over hypotenuse. So that is square root of 105 over 11. And that means cosecant is 11 over the square root of 105. And then our tangent, opposite over adjacent. So negative square root of 105 over -4. So the tangent here ends up being positive. And then our cotangent would also be +4 over the square root of 105. Now, webwork may want you to rationalize those two answers there. So I'm going to go type that in real quick and see what webwork wants. Let's see. Cotangent 4 divided by square root 105. No, it took 4 over square root of 105. Cool. On the test, certainly I will take it unrationalized. Although I think on the test, this one is multiple choice actually. So I just say whichever answer is equivalent. So not my best explanation. I kept forgetting the negatives everywhere there. Hmm. Now you do have to remember which one is which reciprocal on the test. I don't think I put the reciprocals on there. I put the Pythagorean identities and then all the other ones from exam 3, but I don't think I put the reciprocals. But you do need to remember what's the reciprocal of what in calculus, because eventually you're going to learn derivatives as well. So you have to remember them all to keep them straight. All right, what's another question we can look at? 7. Yep, so sum and difference. All right, so we're given two different triangles here. We're told the sine of alpha is 9/19, and alpha is between 0 and pi over 2. And then we're told the cosine of beta is negative 7/19, but beta is over between pi and 3 pi over 2. So I'm just going to take those and translate them into triangles first. So alpha is between 0 and pi over 2. So that puts alpha in quadrant 1. And then I finish my triangle. Now, since I know sine alpha is 9/19, that is opposite some old hippie O over H. Opposite is the vertical side. So this vertical side is positive 9, and the hypotenuse is positive 19. So I need to use Pythagorean theorem to solve for the third side here. So I've got x squared plus 9 squared equals 19 squared. So that's 81, and 19 squared, I believe, is 361. Mm. So that's 280. Yay, webwork picking annoying numbers. That we square root. And we have to answer the plus or minus question, but we're in quadrant 1. So our side is the square root of 280. I'm just going to leave it as the square root of 280 because on the test, it doesn't, the square root numbers won't get smaller. Now, a question, they might end up in the bottom of the answer and the answer choices might rationalize it, but the square root itself isn't actually reducible. WebWork may want us to reduce that though, so we'll see. I'm going to leave it square root of 280 for now though. So we have sine alpha, so we also need to know what is cosine alpha. That'd be our adjacent side, square root of 280, divided by our hypotenuse of 19. Now, same song, second verse for our beta triangle. Beta's in quadrant 3. Now, on the test, you won't have to do quite this much work because the way we ask the question is actually closer to question 8 rather than question 7, but you'll have to do like this calculation. We just did it on question 3. So you will have to do the whole triangle setup a couple of times on the test, but not too many. All right, so we know the cosine of beta is -7/19. Cosine is adjacent over hypotenuse. So -7 is our horizontal side. 19 is our hypotenuse. So Pythagorean theorem, -7 squared plus y squared equals 19 squared. So 49 plus y squared equals 361. And we get 312. Yeah. And then we square root. We have to choose the plus or minus. This y is going down, so we are going to choose negative square root of 312. Now that we know that opposite side, that is the sine of beta, negative square root of 312 divided by 19. All right, so I got 4 different trig functions there. The actual question was the cosine of alpha plus beta. So on the test, I'm going to have all the formulas on the front of the test, but the very back page of the test, the back side is blank. The front side of that last page is also a bigger unit circle and all of the formulas. And you can rip that off and have that as a reference separate from your tests. You're not having to flip the pages everywhere. So we'd rip off our formula sheet. We'd go look up cosine alpha plus beta. This formula is cosine alpha cosine beta minus sine alpha sine beta. So now we're going to fill in the pieces we know. So cosine alpha we have as the square root of 280 over 19. Cosine beta was that -7 over 19. Minus sine alpha was 9/19. And then sine beta was negative square root of 312 over 19. Webwork should take the answer like this. Oops, forgot to close the first parenthesis. Minus, open, 9 over 19, close, open, negative square root 312 over 19. Yep, it took that answer. The numbers won't be this disgusting on the test, though. These numbers are a little bit bigger than what I usually like for at least these kind of questions. I usually like to keep the trig ratios like smaller numbers. So we used the information given to draw the 2 triangles, found the third side so we could identify the sine and the cosine of each angle, and then just filled those into the appropriate spots. Now the big one is, when I say the sine of alpha is 9/19, that is not saying that alpha is 9/19. I am not writing cosine 9/19 and sine 9/19. I am saying the sine of alpha is the same as 9/19. So when I'm writing this second line, There is no cosine or sine in my answer anymore. But I had a lot of people, like, even though they wrote the final correct answer, they were still writing the sines and the cosines. So when we write statements like this, we're saying the sine of alpha is the same as 9/19. So that means I trade out sine alpha as an expression and put in its place 9/19 as a fraction. It's the whole expression is equal to the whole other side. You have to have the whole thing when you make a substitution. All right, what's another one y'all want to take a look at?
Excuse me.
Go for it.
So I don't have the exam review in front of me, but I still need a lot of help on um drawing the expanded graphs. You know what I mean? Like the ones that have the amplifier or the horizontal shift, the vertical shifts.
Oh, yeah, yeah, yeah.
Just like I guess like a really nasty looking one, if you can make one up that has all of the elements, like the shifts, the
Yeah, problem five.
amplitude.
Problem five does that. The good news
Okay.
is you're not going to have to produce that graph.
Oh, like we don't have to draw it.
Nope.
Oh, we just have to do that.
Yep. In fact, you only have to do amplify, period, phase shift, and the midline equation. You won't even have to do the max or the min.
Could we do it though?
Yep.
Yeah. Thank
So
you.
when we're looking at our function formula, there's 4 variables. We have the a, then it's the sine of b times x minus c, and then plus d. So each of those letters is responsible for one of our 4 questions here. So our amplitude is, of course, just the a value, whatever number is in front of the trig function. So here, that is the number 5. So the amplitude is 5, that part is done. It's not really work, you just got to write down your number. The period actually has a formula, though. So our b value inside the graph is responsible for a horizontal change. The b value is being multiplied, so this is a multiplicative change, which is a growth or contraction, a stretch or a compression. So we divide by b. We do the opposite operation of what the function is showing us. So for our particular graph, 2 pi divided by b is pi over 4. So 2 pi divided by a fraction is the same as 2 pi times the reciprocal of the fraction, 4 over pi. And then the pi's cancel, so we just have 2 times 4 is 8. Normally, though, the period is still a pi number. So if it was just b is 4, we'd have 2 pi over 4, and we'd get like pi over 2. But whatever number you get out of the formula, that's the answer for the period. Now our phase shift is coming from what's right next to the x inside the function. Phase shift is our horizontal shift, left and right. So our function is x minus 3. So this is where the inside lies. It looks like negative 3. It looks like we'd be going left 3. So we're really going to go right 3. So it'll be is 3 units and then right. So I do need to see both things, not just the number, but also the direction. Now, the last part of the test question is going to be the midline equation. Now, our midline equation is our middle line, and it's a horizontal line. A normal, untransformed trig graph has a midline of y equals 0. This particular graph, though, has a vertical shift of up 3. So that means our midline goes from y equals 0 and get moved 3 units up. So now it's at y equals 3. So it's not just about telling me that the graph goes up 3, but that the midline equation is y equals 3. Now, this particular question on the test is not multiple choice. It's free response, because trying to do multiple choice for 4 different answers, like, it would just look like horrible lists of numbers. It'd be real confusing. So this one's free response, which means you can get more than just half credit. You can get close or minimal. So you do want to show some work. So even if you don't get y equals 3, but you at least write up 3, I can still give you some partial credit for that up 3.
And
Now, go ahead.
the max and min is the equation is like d plus 1 or d minus, well, no, d minus a, d plus a.
Yep. The midline value plus the amplitude gives you the high points, the maximum points. The midline value minus the amplitude gives you the low points. So in this case, that is, our D value is 3, so it's 3 plus 5 and 3 minus 5. So we get 8 and -2 for the max and the min on this one.
Okay. And would drawing the graph right now take up too much time for the review?
Yeah, probably.
Okay.
Just because we'd actually have to calculate where the extra x values fall in the whole period length, so it'd get a little weird.
Okay.
But I can explain it after class if you want. I've got enough time. I can do that later.
Okay.
All right, what's another one we can take a look at?
Can we do number 10?
Sure. So number 10 is a trig equation that we are solving. So we've got, I think, 4 different equations that I'm asking you guys to solve. So remember, solving an equation, finding the exact solutions is just finding the values that make this equation true. So that means we're finding, in this case, our variable is theta. So we're finding theta values that when I plug in theta into this equation, the equation would work. I'd get 7 equals 7. So all of our equation solving properties and rules that we've used come into play. So this is a quadratic because it is cosine squared. We have a squared term. So we can get everything on one side so it's equal 0 and use the quadratic formula. And if that's the way you're most comfortable solving quadratics, like, absolutely go for it. It works. In this case, though, since there is only one variable term, the cosine squared, we can also just get cosine squared by itself and then use the square root property. So because there's not a cosine only term, it's only the cosine squared term, I can just solve and get it by itself. I'll have to remember to use my plus or minus on the square root, but I'll still get I'll still get all the same answers. So I'm going to minus the 5. So I have 8 cosine squared theta equals 2 now. And then that 8 is attached to the cosine by multiplication. So I'm going to divide both sides by 8. So now I have cosine squared theta equals 1/4. Now we're getting rid of that squared. I cancel out squaring something by square rooting it. But anytime I choose to write the square root, I have to remember the plus or minus. Now here, when we're solving an equation, there's no context clues for whether we pick the plus or the minus, so we actually keep both. So I'm going to split this into two equations. I'm going to have cosine of theta could be positive 1/2, or cosine of theta could be negative 1/2. Because the square root of 1/4 is 1/2. I know that's a little counterintuitive because I square rooted a number and my result is bigger, but that's because the number we square rooted was less than 1. So all of the numbers in between 0 and 1 work really weird with square roots. Like numerically, the square root of 1 over the square root of 4, like that makes sense that that's 1/2, but size-wise, it feels a little weird. But we are doing the math correctly. Now, this step is where we go to the unit circle. So cosine of theta is 1/2. That's the x-coordinate. The x-coordinate is 1/2 at pi over 3. And then in quadrant 4 at 5 pi over 3. Now it turns out our negative 1/2 are going to be the other over 3 angles. So we're going to get 2 pi over 3 and 4 pi over 3 as the other two angles in the list. So we actually have 4 solutions to this equation. So if it was just cosine theta equals a number, the little equations that we got in here, each of those have 2 solutions, but because of the plus or minus, we ended up with 4 solutions. So a quadratic trig equation can have up to 4 solutions. Usually it will have all 4 solutions.
For the unit circle, what are we looking at again? Like when cosine equals 1/2?
So cosine theta equals 1/2 when the x-coordinate on the unit circle is 1/2. So it'll be like 1/2 and square root of 3 over 2. This is pi over 3. And then
Oh,
5 pi over 3 is 1/2 and negative square root of 3 over 2.
oh, okay. Thank you.
So like we're looking for the coordinate and then we're backtracking to what is the angle that produced that coordinate. So we're using the unit circle a little bit backwards direction. Now, technically, each of these are supposed to have plus 2 pi k. But the only k value that produces solutions is k equals 0, and it produces those 4 solutions we got from the unit circle. So our original question had the given interval from 0 to 2 pi. And those are the only 4 solutions on the original unit circle. The plus 2 pi k gives us coterminal angles, but the coterminal angles are all the rest of them are either bigger than 2 pi or less than 0. So if you don't write the plus 2 pi k on this one, like you still get the right answers. Now the other trig equation though does require the k value. And that is problem 11. So the start of problem 11 is shorter, but then when we get into our answer from the unit circle, Then we've got more work because we actually have k values to mess with. But the start of this still, we're trying to get theta by itself. So my first thing is I'm going to divide by the 2. So I have the sine of 3 theta is equal to the square root of 3 over 2. Now this step here, I'm getting rid of the sine function by using my unit circle. So I'm looking where the y-coordinate is square root of 3 over 2. So this occurs at the pi over 3 angle and the 2 pi over 3 angle. Sine is positive in quadrant 1 and quadrant 2. Now, our inside angle, though, expression was 3 theta. So I have 3 theta equals pi over 3, and 3 theta equals 2 pi over 3. So this is the step. Like when I use the unit circle, this is where I put plus 2 pi k for all of those coterminal angles. Now I'm getting theta by itself, so I need to get rid of that 3. So I want to divide by 3. Over here, I can write it as all over 3, or I can write it as all times 1/3. And since I've got fractions and addition in there, I usually like to write it as a number to the side that's being multiplied, because that number is going to need to distribute across the addition. So I finally have theta by itself. Pi over 3 times 1/3 is pi over 9 plus 2 pi k over 3. And then for my other side, I get 2 pi over 9 plus 2 pi k over 3. So like just coming up with the general solution, that's what we call the ones with the k formulas. Like, not that bad. But now we've got to pull, there is actually, because we have 3 theta, there is actually not just the 2 solutions that we see here, but there's 4 more. There's 2 more sets. So we are going to use k equals 0, k equals 1, and k equals 2 to find all of the solutions here. Now on the test, like having to do 3 k values or 4 k values, like that's just a bunch of extra busy work. So it's only going to be 2 k values. You're only going to have to use 0 and 1 on the test. But we plug in 0, and I will get theta is pi over 9 plus 2 pi times 0 over 3. Well, all of that is just 0, so this is just pi over 9. Our other angle, 2 pi over 9 plus 0 is going to be 2 pi over 9. So my first 2 solutions I can get, even if I forget the 2 pi k, I should at the very least get those 2 numbers. For k equals 1, now I have pi over 9 plus 2 pi times 1 over 3. So I'm doing 1/9 plus 2/3, because the pi's are in both fractions, so I know my answer is just going to have a pi in it. But I would need a common denominator, so I'd have to multiply this guy by 3 over 3. So I'd actually have 6 pi over 9. 6 pi over 9 plus a pi over 9 is 7 pi over 9. And then our other one, we're going to have the 2 pi over 9 plus 2 pi times 1 over 3, so 2 over 3. So that one is also, I need to multiply by 3 over 3. 6 plus 2 gives me 8 pi over 9. Same song, third verse. Pi over 9 plus 2 pi times 2 now over 3. That's 4 pi over 3. It still needs to be multiplied by a 3 over 3, so that becomes 12 pi over 3 plus pi, gives us a 13 pi over 3. Did I do that right? 12, 13, yes. And then 2 pi over 9 plus the same, 2 pi times 2 over 3. We get 14 pi over 9. So all 6 of those are the answer to this one. Now it'll only be 4 answers on the final. So you'll have a 2 theta equation that'll give you 4 answers, and you'll have a trig function squared formula that'll give you 4 answers. Both of those are going to be free response, so you're not going to have answer choices to like pick and back solve here. You got to show your work. But that means you got plenty of room for partial credit on these.
Excuse me.
Go for it.
Isn't there a specific and I think this problem is different, but isn't there a specific formula or equation for like cosine 2 theta?
There is actually. So cosine 2 theta actually has 3 different formulas. There is cosine squared theta minus sine squared theta. There is 2 cosine squared theta minus 1. And there is 1 minus 2 sine squared theta. All of these are equal to cosine 2 theta. All of them can be used as a substitution for cosine 2 theta. So if you're given cosine 2 theta and you're being asked to solve for it, technically you could make one of these substitutions for it. And that might make more sense for solving for you, but if you're solving an equation for cosine 2 theta, you can also just do it the way we did here, like move any numbers around, add or subtract, multiply, divide, till the trig function is by itself. Figure out what angles make that trig function in general true, and then you just have 2 theta equals angle, 2 theta equals angle. So you can do it this way. If you make the substitution, then you'll probably want to use not the first one, but one of the bottom 2. But you'll end up with a quadratic. So it'll be more similar to the way we solved problem 10. Yeah.
Oh, okay.
But you would still get the same 4 answers.
Okay. But you wouldn't have to use the 2 pi k.
You wouldn't have to use the 2 pi k if you made one of the substitutions, if it was cosine 2 theta. If it's sine 2 theta, then I would still go with the 2 pi k way. Because sine 2 theta, the formula for sine 2 theta isn't as nice. It's 2 sine theta cosine theta. And figuring out like, how do I produce a product of 2 things? Like it's not as straightforward. It can be done. It's not impossible. It's just, it's a little weirder.
Thank you.
Boop. And that is time. All right, let me stop the recording.